Good evening, all. Uh, where is there? Okay. So thank you, Shagib. And today I'm going to show about some open source IoT tools. Like this is a new thing to the. I hopefully is for new things to Kayash. And so I'm going to show a bit enabling the scalable, secure, and interoperable IoT deployment. Some open source deployments I want to show here. And here mostly how to consider done. Here are some open source rule, like whether you heard about or not. So the first one noted for showing some visual programming, like how the IoT device to be integrated with the system. Like yesterday heard about the Rupik file layer, Rupik file, like that much of deployment we can able to do that. So also this node rate can be we can able to deploy it for our cloud setup and IoT exchange of some communication protocol. We can able to do that, and we can go for Eclipse. Mosquitto is a very good protocol, which is called MQTT. It's a message queuing telemetry transfer protocol, and for messaging. And third one is a very fantastic device management for us of IoT, which is called Thingsboard, and will show one by one. So now the wooden open source IoT ecosystem offering compared the cost-effective solution with the flexibility of the customization of the LTS support. And for this first one, node rate, I just use for a low code program. Just you can plug and play just to how to install the command sudo space snap space install node rate, and you can deploy to the put the command of node rate. And this is the easiest way to collect and transfer the displays the real time data. Just you can plug and play of all your the modules in the IoT. You can plug in and you can able to simulate. And this mainly is here for the home automation and the industrial automation. Like all the industrial automation now they are focusing on this type of node, right? And this is a snapshot of this node, right? Like you can install this command and just you can plug this. So what all the things you do you need for this any IoT, like you can integrate it here. Just you can plug and play it here, and you can able to simulate it. It's a very good platform where you can able to do that all those things platform. And when you go for the Mosquitto, it's the next one. It's going to be available in Ubuntu repository, so you can install, like you can add the repository to the Mosquitto, and using PPA, then you can sudo update you can give. So it's a very proprietary responses where you can connect your IoT device like Rubik Pi. You can able to connect there, and you can able to exchange the like if just to have the two things. One is called the publish and subscribe. Like YouTube, you have no publish and subscribe. Like we have this model, like we have to publish some information to that. So first you can get the topic. So which topic we have to publish, then we have to take the subscribe, and we can do the publish using some message conversation. So it's going to be a Mosquitto publish hyphen like what topic you want to publish and which message you have to publish. That is the thing you can able to do that. It's a very good formatted software. So it is a central component. So here the broker can act as a component which can communication between the client and IoT device we can able to communicate. So we have some model which is called publish and subscribe model, and this can be a mission to mission message with low power sensors and mobile layers to be connected. And if I have connected to this Mosquitto, and we are listening the port number where I can able to free and which port is going to be free, and I can able to deploy this port, and I can able to use this publish and subscribe model here. And Thingsboard is also the another open source IoT platform that data collection, pre-processing, visualization, and device management can be done very easily. Even for nowadays, the power consumption the major factor. So I'm using the energy management factor to and using like as per the biology I asked. So where you apply this IoT in the rural areas, I can able to apply this device to the agriculture farmers can able to. This forum can be very useful for the agriculture for farmers. Like they can for the cultivation, this is the board, like this is going to be open source IoT platform where you can simulate distance. So I can fit some 3 sensors here, so you can able to set up, so you can move this is actually an agriculture land where you can move somewhere else, and you can change the temperature of my my land, and my crop level, my productivity of the crop level, and I can see the soil erosion of my land. Anything I can able to watch it in my home or in anything else, and I can able to operate it, and I can see. So any like you can, whether the temperature is high or you have some soil erosion, then it will be indicated by this forum, like some chart and some other things it can able to simulate, and it will show the output. And for I'm using one sensor here that is going to be LoRa sensor. Like how many of you heard about LoRa sensor? Any idea? Yes. It's a low power long range communication. So within 2 kilometer. Yeah. So Bhavan Singh. So 2 kilometer, maximum 2 to 3 kilometers, you can able to cover it from your home. You can able to operate this LoRa. Cost around is going to be 2,000 or 1,800 rupees. I don't know. So we are applying this LoRa sensor. Like we are applying this. Farmers can automatically farming. So here I'm using the both AI and the IoT. So AI for I'm using the drone camera for capturing that. But now the Rupik Pi yesterday I heard about that is also you can camera. You can fit it to the land. You can able to surveillance using this forum. And this I'm using in the COOJA simulator. It's one of the open source simulator where you can able to simulate. And this will be a what is it? So I have my agriculture field in Word. So I'm using my IoT sensors there, and I can collect the data. And using some data analysis AI techniques, I can able to put in the some best fair condition. Whether so here I'm going to maximize my crop productivity. So because my crop productivity is a major issue for all the farmers around the globe. So I'm going to improve the crop productivity of the what is it in the thing in the rural areas, especially in the rural areas. I'm using the that LoRa sensors, which can able to predict the future outcomes based on the current and past condition, which can help the prevent crop diseases, which have some pest infestation. And IoT and AI technology has been transferred to this COOJA simulator, and probably I have this one. So my autonomous vehicle, like I am using drone camera, but now we can connect the Rupik Pi also. So I can able to connect this autonomous vehicle to be connected, and it will be connected to the some towers. Then I can capture the data. So data collection to be done, and it will be stored, and it will be forwarded to the cloud storage. So I'm using here. I'm using one open source. Uh, Software like Thingspeak. Is going to be a cloud, so we can able to use that Thingspeak. I can able to collect this data, and I can able to do it, and I can see a best behavioral condition of prediction of my data using some charts. So this hardware, it's going to be inexpensive, so we can very less cost. We can able to what is it? We can able to deploy that, and it's going to be wireless connectivity deployed to the large number of agricultural fields. So the hardware modules can be installed and to check the soil condition and other weather condition, etc. So I can use the GPU to process the large number of data collected by these modules of LoRa modules, and so based on the software AI techniques, I can implement. So I'm using both AI and big data here. Like I can able to predict the data. So the IoT sensors, autonomous wheels can collect the data for the analysis, final best behavioral conditioning argument. So this is my LoRa device. So I have connected either Arduino Uno's module is connected to. So Arduino Uno is actually in my where Arduino Uno is in my it has some temperature sensors also in my LAN. It's been connected to Arduino Uno, and I have connected this connection to my LoRa. So there are Arduino Uno is there, LoRa is there. So LoRa I can operate from my home. So I can connect it to the Arduino Uno with the LoRa modules can be find the humidity, temperature, and soil elevation of the agricultural land. So I can simulate this using COOJA simulator, a series of simulation to be done, and you can see that some output condition using ThingsPeak Cloud. Okay, so you can log into ThingsPeak app, and you can log in. You can see the best behavioral results. So these are the clients I have done, Arduino Uno and LoRa, and some temperature sensor. And for AI, for AI, for I'm using tone camera. So the novelty and uniqueness of this. So soil erosion, traditional farming are insufficient to meet the soil erosion failure for the crop production and crop disease and pest infestation. But now, by novelty, I have minimized the crop diseases, minimizing the pest infection, better productivity of my crop productivity to be done. And so the conclusion maybe every year, so we need of food. So so in order to implement this IoT, the AI, so I can maximize the crop productivity to saving the resources like water irrigation and minimizing the toxic chemicals such as which is the fertilizer. Like fertilizer is a very very important factor. Every year farmers can die something like in the rural areas and all. Okay, some known or unknown, I don't know. So they have what is it? Died because of this fertilizer and some are pesticides and herbicides. So I can save the time with the low cost smart agricultural AI based open source devices. Open source devices, you can learn this word. Open source devices availability is easy for the farmers for the good agricultural production. So benefit to the society. So you can drone spreading fertilizer in a couple of minutes. Now in all the like in the villages and all, now they are not using human beings. So the drones will be used now. For half an hour, they will for 1 hour they'll ask some 300 rupees for fertilizing. So 1 acre of land we can able to do for within the 10 minutes or some 15 minutes for train fertilization of the like they have done within a couple of minutes. So I'm minimizing the fertilizer, maximizing the crop productivity, and I can save the cost and time, and say I can save the human effort also. Sorry. So that's all about my thing. Thank you.